Hi guys, welcome back. Today we are going to talk about viruses and we're going to talk about populations. And I'm going to try to keep it short because I keep doing this and I'm hitting a lot of minutes. So we're going to try to do it quickly. If you remember, for the last couple of weeks, we've been looking at populations. When we left off in this actual space, we were talking about populations. And then you had an assignment where we learned about bacteria and viruses. And then last week you watched a couple of different videos about pandemics and epidemics and how viruses are going to spread or jump species. So today I want to look at really quickly what viruses look like, how we classify them, and then also how they reproduce and kind of how we can get rid of them. So the first thing we want to look at is what a virus is. Viruses, in most books, there's a little bit of some thoughts out there about the way we say these words, but most of the time viruses are considered to be not living. Is that going to change? Probably. As of now, your textbook still considers the viruses to be non-living. And with those viruses, even though they are not considered to be living, they are able to adapt. They're able to infect people. They need to have a human or some type of host in order to make them be able to survive. What is a virus? A virus is basically a protein with some DNA or RNA on the inside of it, and then there's other stuff like maybe lipids. So remember, those lipids are non-polar, so they are not able to be dissolved in water. And then usually some protein receptors on it as well. And the reason why they have those proteins and they have those lipids on the outside of them is so that when your cell encounters that virus, your body doesn't realize that it is a virus. Often they will mimic sequences that are very similar to your own, so it takes a while for your body to realize or to recognize that there's a virus there, and then it takes even longer for your body to make an immune response to get rid of it. The different viruses, I just drew this one here. Yes, I know, it's the Jimmy Neutron virus, also maybe the tobacco mosaic virus. But with these ones, it's generally the one that you see when people draw a virus. Viruses can infect all living organisms. So bacteria can get viruses, fungus, animals, plants, anything that's living can get a virus. And generally, they're going to stay within that species. Cats get cat viruses, dogs get dog viruses, humans get human viruses. And that is because of their DNA that's inside of it. So the DNA maybe that's in a cat virus or the RNA that's in a cat virus is very similar to what you would find in a cat. And maybe it's really, really different than what you would find from a human. So that's why humans don't always get cat viruses, because our DNA is different from a cat's. These protein receptors, again, that's the other thing that's going to be really important. So the proteins and the lipids on the outside of the virus would be very similar to a cat's. Again, not similar to a human's. My cat sneezes and I breathe in cat virus, my body automatically knows that that is not something that I need to keep in my body, and it'll automatically kill it. Okay, very important with those. Once you get a virus, however it comes in, often it comes in through the mucous membranes, your eyes, your nose, your mouth, skin sometimes, blood, sometimes it'll come in, again, depending on the type of transmission or the type of virus it is, how it's spread between populations. But whenever it comes into your body, again, most of the time, your body doesn't even know it's there. Viruses have such similar protein coats around them that your body doesn't always see it right away. And so the virus uses that time to start working and to start making new viruses. And viruses can't reproduce on their own. They have to have your cell to do it. And they do it one of two ways. The first way that they do it is what is called the lytic cycle. I was thinking about drawing, but I'm not sure. In the lytic cycle, to lyse, or lyso, if you remember, means to break or to split. So in the lytic cycle, with that root lyse, something's going to split. So what the virus does is the virus injects its DNA inside of your cell, inside of the host cell. And then it hijacks your DNA so that it causes your DNA to stop manufacturing whatever protein it was supposed to be manufacturing, or stop doing whatever it's supposed to do, and it causes your cell to start making a whole bunch of tiny little baby viruses. And then it assembles them. And once it assembles them, it's so many inside of that cell that it causes your cell to lyse open or to burst open. So in that case, now where you maybe had one virus inside of your body, now because your cell manufactured a whole bunch of more little baby viruses, now you have 20. And each of those 20 viruses are going to go to 20 other cells, and they are going to make 20 more viruses per cell. And it's going to be a while before your body even realizes that it's happening because of that protein coat, and it'll often take little pieces of your cell membrane, your phospholipid bilayer, to kind of mimic themselves like a cloak of invisibility so that they can go through your body and keep manufacturing these little viruses. It's what we refer to as an incubation period. So when you hear people talking about an incubation period of a virus, it's where you have it. You're maybe manufacturing a whole bunch of more of this virus, but you don't feel any of the effects from it because your body hasn't recognized that it's there yet. You might find that you're extra tired and you just kind of feel sluggish because your body is working really, really hard. But your body's working really, really hard to manufacture a whole bunch of viruses. And it's before you get the runny nose, before you start to feel sick, like actually sick. You just might be tired. So that's the lytic cycle, where cells are going to manufacture little viruses. The other is called the lysogenic cycle, and the same stuff kind of happens, where the virus injects its DNA inside of the host cell, but now it actually becomes part of the host cell's DNA as well. So every time your cells divide, your cells are going to divide some of that viral DNA as well. Those ones are often a lot more difficult to get rid of. So when we're looking at how the viruses are going to reproduce or how the viruses infect your body, it's often by the time that you start to feel sick, your body has been working and working and working and working and working to manufacture a whole bunch of little viruses. So now your body has to get rid of them. If you're sick and you have a sniffle, or you're feeling like really awful, and you go to the doctor, and you're like, I've been feeling super awful for 2 days. Your doctor's probably gonna say, I'm not gonna give you anything, it's probably a virus. And viruses often are gonna last a lot longer. It might be 7 days, 10 days, 2 weeks before you start to feel better, because your body now has to find every single virus that it helped manufacture, and it has to kill it. We don't have anything that's going to really help you once you have a viral infection. So if you have a cold, taking an antibiotic isn't going to do anything for you because it's a virus, and those antibiotics only kill bacteria. We talked about that in yesterday's lesson. So when you have a cold, the best things for you rest. Don't do too much stuff. Just lay there on the couch or in bed or wherever you're at and just watch The Price is Right, watch some TV, whatever it is that you need to do, but just relax. Let your body do its job. Eat some food, drink lots of fluids. If you need to take medicine, maybe you're coughing a lot or you've got a lot of mucus, you can take that. It's not going to kill the virus, but it's going to help you feel better so that you can rest, so that your body can do what it can do. The only thing that really can help with a virus is a vaccine. And with those vaccines often-ish, really, really general right now, it's going to be, they'll give you the empty protein coat. So maybe without the DNA or the RNA or something. So what it does is it's kind of like a preview. It's a preview so that your body knows, oh, I've got this thing and I don't know what it is. What do I do with it? What is this strange protein coat? So your body then is going to find it, and your body is going to say, I don't really like you, and it's going to start manufacturing the antibodies. There's going to start manufacturing some of the stuff so that the next time your body encounters that it's going to kill it. So think of it maybe like chickenpox. I'm old, so when I think it was 12, and it was Easter. I definitely know it was Easter because I got a really pretty Easter dress, and I remember my mom zipping me up the back of my dress, and she said, what is all over your back? And I had these little red bumps all over my back. And it turns out I had chicken pox. I didn't know I had chicken pox. The night before, I had been hanging out with my brother's friends and their whole family. So I infested, I cannot think of the word right now, but it ended up that I got chicken pox, my brother got chicken pox, his friend got chicken pox, I think his two sisters and his aunt and my aunt, everybody got chicken pox because I was contagious and I didn't know. So I got that. I'm probably not gonna get chicken pox again. I had it pretty bad. So if next time I'm around the chicken pox, so I could be around all those other people who got chicken pox weeks later, I wasn't gonna get it again because my body had already manufactured the antibodies, or had already manufactured the defense system. So if I came into contact with that again, my body would immediately kill it. Most of you have not had chicken pox. Most of you have had the chicken pox vaccine. It does the same thing, only instead of you having those itchy bumps for the next week of your life while your mom makes you scrub the laundry room floor, although when your brother gets chicken pox, he gets to go to the batting cages to practice for baseball. Not that I'm bitter at all about that. But, so you don't have to get the chicken pox. So when you come into contact with chicken pox, because you got the vaccine, then your body automatically knows to kill it. So what we are finding though is that people who got the chicken pox vaccination often as adults would get shingles. It's the same virus, it just changes a little bit as you get older. So you'll get a booster shot. I think you get that booster shot before you go to college, just to make sure that you don't get it again. And it's just like a reminder for your body, like, hey, let's produce some of these antibodies so we don't get sick. That's why you get your vaccinations, so that it's your body's way of manufacturing, or it's putting up a good guard just in case it comes into contact with something later. The way I tell my children about their vaccinations is I tell them that they're getting teeny tiny little ninjas. So they're getting these teeny tiny little ninjas that are all through their body, so that whenever those teeny tiny little ninjas come into contact with one of the bad guys or one of the bad viruses, those teeny tiny little ninjas are gonna kill it. That's basically what a vaccination does. So quickly about this current viral outbreak, which is why, again, I'm here and you're not there in your seats. This is new. So this is one that humans haven't really encountered before, or if we've encountered it, maybe we didn't know we were encountering it. So none of us have those teeny tiny little ninjas that are trying to fight it off. We've not experienced stuff like this before. So it's why it's gonna go through our population and we're gonna see higher numbers of people getting ill rather than something else that we see all of the time. Yeah, so it's new. That's why it's called novel, new. I think that was one of our roots at one point, or would have been eventually. So it's a new virus, something we haven't encountered. We should expect that more people are going to get this virus because we've not come into contact with it before. What else do I want to say about it? Oh, I was reading about it, and one of the things that I saw was that it has a ton, where'd it go? There we go, of lipids. All of those little pointy ball things are supposed to represent lipids. So they're nonpolar. So the reason why we keep saying wash your hands for a really long time, is because that virus has that nonpolar coating on it, and that soap nonpolar. So scrub, dub those hands. It's going to help get rid of it from your hands. I think that's about it. If you have any questions, please email me. You can email me at my school email. You can email me through Google Classroom. You can find me on my Mrs. Kania Instagram. It's the kania.life.lessons. Or you can also Twitter me at StacyK628 if you have any questions. Please make sure that you are doing your FIDS assignments. There is no assignment for yesterday or today, it's just to watch this. But I am going to be sending something to go along with this for Friday, and it'll take, or for Thursday, and it'll take a day or two of next week as well. So I hope you guys all have a very wonderful Easter. Fun fact, the last time I saw you, I said, may the odds be ever in your favor and happy Easter. I was really just being a jerk, kind of, and being funny, but we're really not gonna see each other for Easter. So I hope you have a great spring break. Take some time and just rest, and stay healthy, stay away from each other. Please keep sending me those memes. your meme game has gotten real weak in the last like 2 weeks. So any memes or videos or anything like that, I do enjoy them. It helps break up the day. I hope you're all well. Happy Easter.